So, you have essentially 3 rules on how to condense or expand. So sometimes, depending on the problem that you're dealing with, it makes more sense to expand something, and then other times it makes more sense to condense. And we'll get into when each of those is appropriate when we get to solving log equations. But for now, it'll tell you either to expand or condense. So these right now are all already condensed because they're a single log, right? But the idea of expanding would be in case you ever wanted to evaluate and you didn't know what the log of m times n is, but individually you knew the log of m and individually you knew the log of n. And if you expand it and know them individually, then you can come up with the values. So when you're taking the log of 2 things that are getting multiplied, does anyone remember how that expands? So you're telling me I have a purpose. Nobody? Trista, I feel like you know. Addition, so tell me what to write. Perfect. You don't need me after all. Trista could tell you. Let's see if you could do this entire thing without me telling you anything. Who wants to tell their classmates about the second one? Aiden. Are you saying log sub b because Trista did? Or is that what Mrs. Ziggy said? Okay. Because I think most math people would say log base b, right? If it's sequence and series notation, you'd say a sub 3 in that notation, but typically with logs you don't say sub. But I was just curious. And the last one. Come on, prove that you don't need me. Prove that you're self-sufficient. Nobody? This is the easiest one. This is the one you use the most often. For bonus points, would you tell me? P times log base b of n. That's where your exponent that's on whatever you're taking the log of would come out in front. That's the one that makes logs the most useful. Because if you're trying to solve an exponential equation and you're trying to solve for an x that's in the exponent, you take the log of both sides, which allows you to bring that out in front, right? Okay, so go ahead and expand as many as you can down below on your own. Let's just start with the first 3. We'll talk about them, and then I'll let you move on, because they do get harder towards the end. All right, first one. Marissa, what do we have? Anybody disagree? Next one, Mitch. Anybody disagree? Next one, Bridget. Three cubed. Keep going, I missed the rest. Anybody disagree? Olivia? 3 minus? Because she's seeing that, right? So that would be, yes, the extra step that you would need to take. If that didn't happen to cancel, you could take that 3 out in front as well and do 3 ln of E minus ln of 7. Okay, keep going. Raise your hand if you're already done with the next 3. Okay, just a couple of you. All right, keep going though with the next 3 or the next 6, wherever you are. All right, next one, Andrew. Anybody disagree? Next one, Abby. Anybody disagree? Mackenzie? Anybody disagree? Trista? Right, you're just not quite done. 2 log base b of x plus a half log base b of y. Next, Sarah. Anybody disagree? Next, Connor. Anybody disagree? Okay, this is probably the hardest one on the paper. Aiden, what is your thought? Right, okay, so let me back up and get everyone else caught up. So right now, by bringing that 4 out in front, you actually treated it like it was this, right? That 4 is really not on the 36. It shouldn't have been anyway. So you're actually not quite ready, because those parentheses really weren't there. You're not quite ready to bring that 4 out in front, because that 4 is not applying to that entire piece. So what you would need to do first is split this up into, what did you say, Aiden? Now, on top of that, what's wrong with what I have here? John? Well, I will. Okay, so he's saying bring that 4 out in front of that log now. But still there's something wrong with this. Mitch? Right, exactly. We are subtracting a monomial here, so we don't need parentheses. But because this monomial turns into a binomial, we want to make sure we're subtracting the whole thing. And so then we would distribute our negative, and this would actually turn to a minus 4 log base b of y. So that, definitely the hardest one on the paper, because there's some like division, and within the division there's multiplication, and within some of that there's exponent stuff. So this has all 3 rules that you have to kind of think order of operations wise through and keep those parentheses, and that's a tricky one. I don't think it's a tricky one to follow. I think it's a tricky one to remember all the little things as you're doing it. And then the last one, Nate. Say it again. So what rule of the 3 would you apply first? Actually not on this one, because we can't split this up, because right now it's locked in a set of parentheses that's got a 5 on it. So we actually have to address the 5 first. How do I do that? Okay, now what? So tell me what to write. I'm not writing the base 10 because we know it's there, right? Just like that. Anybody disagree? Olivia? Right. Again, you're taking a monomial that has a 5 out in front, so it didn't need parentheses, and you're turning a monomial into a binomial that has a 5 out in front. And yes, you need to put that 5 out in front. Okay? And so that would end up, if you did distribute it, obviously 5 log 4 plus 5 log x. Just for the record, just to show you, if you didn't apply a log property at all first, and you just raised the 4 to the 5th, and the x to the 5th, everyone see that? You could then turn it into addition first, log of 4 to the 5th plus log of x to the 5th, and then your 5s would come out in front, 5 log 4 plus 5 log x. Same thing. All right, that is that. Any questions on any of those? Okay. Now in the back, we're condensing, so go ahead. Work on these 4. John, what'd you get for the first one? Good. Now it didn't say to evaluate, but we could on this one, right? 4 to what power is 64? Next one, Joe. Anybody disagree? Next one. Olivia. Anybody disagree? So we didn't see some of her intermediate steps there, but it's log of x to the 1/2 where that's coming from, plus log of x minus 1 to the 4. And then that turns into multiplication to give you the single log. Good. Oh, next one. Andrew. Oh, you did. Can you send me your paper? Sorry. Is this the first time I asked you to talk today? I didn't know this was the first time. Poor thing. We'll show you what he put. So the first thing he did was move this to an exponent, move the 2 to an exponent, and move the 1/2 to an exponent. Good. Then he turned this into division. So there's his x to the 4th over 6 squared. And then also, once he had this, let me just do an intermediate thing here. I'm going to make it 36 minus log base b of root y. And then once he has this subtraction, he's going to turn this into division, which is where we are here. The only thing I would say here is that we should not leave complex fractions, right? So fraction divided by a non-fraction, we're going to keep, change, and flip root y into 1 over root y. So it'll just be x to the 4th over 36 root y. Okay, so did you do something different? Hand me yours. Yeah, there are definitely a couple different renditions of this, I think. So because there were 2 negatives, and John obviously somewhat foresaw that complex fraction situation, whether you just had a feeling it would go bad or you actually knew that that's what it would turn into, he pulled out his negative first. And then he did the division of x to the 4th over, and then he did a product of these two, 6 squared root y. No problem. So he foresaw that complex fraction, which was really a good intuition, and turned that into multiplication, and so then he didn't have to deal with the complex fraction. So either way is fine. They're the same either way, right? Yeah. Nice. Nice. Okay. Oh, look at John, or is it Andrew? Going ahead on the bottom there. We'll give you later. All right, so the change of base formula, you guys probably got away with not knowing at all last year. Do you remember even talking about it? She probably mentioned it. She probably didn't talk about it a lot because you guys had your calculator last year. You could just type it right in. There's obviously a way on your calculator to type in, oh, what was it, math? See, my calculator, when I grew up way back in the day, we didn't have this calculator. Ours didn't have the log base option, so I don't even really ever remember where it is. I have to search for it. There it is. Under math, log base, and this kind of sets it up so you're able to just plug that in. But on the calculators that I use, there was not that option. And so if you wanted to figure out the value of log base, well, log base 10 of 20 is a silly one because if you just hit log of 20, it assumes base 10. But if I ever wanted to find the log base 5 of 140, I was not allowed to just go into my calculator and do that because that wasn't an option. I had to use the base change of base formula, which is the log of 140 divided by the log of 5. Or you could do it with a natural log. The natural log of m over the natural log of b. Log base is whether they're both log base 10s or both log base e's. In other words, the natural log, it doesn't matter as long as it's the same log on both. Okay? So even to this day, I find it more time consuming to go into my math menu to pull up that log special functionality, and I just still to this day type in log of 140 divided by log of 5 because it's just, to me, it's so much faster. Okay? So, if I evaluate this one with natural logs, that's me just using the change of base formula, so that's just the ln of 140 over the ln of 5. Same thing. So I'll show you that, and again, you could do that too, because your ln button is very accessible. So log of 140 divided by log of 5 gives us the value. Natural log of 140 divided by the natural log of 5 gives us the same answer. And obviously, if I did go do my log base, which I apologize, it's like watching your grandma try to work her email, right? I eventually get there. It just takes me a lot. I don't know. You guys just didn't have to think about the change of base formula. So all you've ever used is the log. You guys probably have a shortcut to get there too, don't you? Oh, so you're telling me that even this one's old? Okay, throwing stones. On the newer ones, what? So on the math, right, like a TI-83, if you're using like a siblings calculator or your older cousin's calculator. Alpha window. I knew there was a shortcut. And then option 5. Does that work on the 84 plus? It must. Yeah. Well, I knew there was a shortcut. I already defended myself. I don't use it. Log base 10 of 20 is kind of silly because you would just type in log of 20, given that the base is 10, and that's what your calculator does. Are there any questions? Negative? Oh, 9? 9 questions? Oh. I had a German Shepherd once that knew German. Are you not impressed?